Okay, looks like we're live. Hello, everybody. I'm Bret DeSell. I'm a brand experience manager for NETGEAR Business, and I'm here today with Bradley and Doug, and we're going to be talking about using access points in a home, in a home environment, to either replace or augment your existing wireless. And access points are generally considered a product for businesses, but they can definitely be used in homes, and a lot of people do use them. So let me introduce everybody. So Doug here, would you like to go first?
Yes, hi. This is Doug. I am one of the product managers at NETGEAR in the business part of NETGEAR.
And Bradley?
Good morning, everyone. My name is Bradley. I'm the Director of Product Line Management for small and medium business, so SMB business products at NETGEAR.
Great. So let me just give a little background on what NETGEAR Business is. The primary products that NETGEAR Business produces are the switches that you will see from NETGEAR, and also access points, and also the Ready NAS products, so NAS storage. Is there any other? There's a few other things like routers, a few types of routers and things like that. But definitely the primary products would be the access points and switches. Also the Orbi Pro, which is a type of access point. So let's first get into this is a question for Doug. What exactly is an access point, and how is that different from, let's say, a normal home Wi-Fi router?
Okay. The way I would look at it is that the biggest difference is in the form factor. Most of the routers, Wi-Fi routers, are desktop. You put it on a table, cadenza, put it, behind your modem gateway. An access point right off the bat, if I were to design, or I'm told to design an access point, the first thing I need to do is put it on the ceiling or put it on the wall. That's all, kind of from a form factor standpoint, that's how it looks. But functionally, the biggest difference between an access point and a router is access point is a layer 2 device, right? It plugs into a router and behaves as a layer 2 communication medium, just like a switch. An Ethernet switch will plug into your notebook computers through the Ethernet cable. The access point is a wireless layer 2 device. So that's I would say those are the two biggest differences between a router and an access point form factor. And logically, one is a layer 2 device and the other is a layer 3 device.
Okay, thanks for that. And just for people in the stream, I see we do have some people in the stream. We will be answering questions throughout this, so go ahead and send your questions, and we'll try to get to them during the stream. So if you have questions about access points, we're going to be talking a little bit about power over Ethernet, and also about our system called NETGEAR Insight, which is a way of managing access points and also certain NETGEAR switches and some other products remotely or through your desktop. So we'll be talking about those various things during the stream. So just wanted to show what I have here. This is just a very small switch. This is not a PoE switch, but you're saying that a switch is a layer 2 device. Can you go a little bit more into what that means for a customer, or if you kind of just how does that equate? What does that exactly mean? Because one thing I did notice when I used an access point is that devices connected to that wireless access point, when I looked at them from my router, it listed them as wired devices, the devices via the MAC address. So just curious, what does layer 2 mean exactly for someone who's using a home network? And how would you kind of explain that?
Right. So first of all, I think from my colleagues, I'm hearing that the audience today, the people joining the call are somewhat technical. nerds, geeks just like me, so I'll go a little bit technical. But do stop me if I'm not talking at the right level of technical technology with you guys. Okay.
Sure.
So the layer one, layer two, layer three. I mean, the most obvious, the most fundamental difference is one operates at an IP address level, and the other is MAC address level. MAC is individually designated to each and every device. Any network device in the world has a MAC address, right?
Yeah, MAC.
IP, right, MAC address. IP address is something that the service provider assigns you, right? In your home, you got one IP address.
That's right.
So IP address is what's called a layer 2 address, right? And then once it gets into the home, for various reasons, and there are a lot of historical reasons that we can get into, once it gets into the home, each individual device desires to have its own IP address. So how does that individual device, your PC, your cell phone, your all other devices get that IP address? It is designated or assigned by the router. That router has a very fundamental job to perform, that is taking one IP address from the service provider and then fan it out, spread it out to multiple IP addresses to each individual device in the home. So therefore, that router performs a, what's called a net address translation function, right? So what does the access point do? The access point does not perform any of those functions, right? The access point takes the IP address from the router. Now it has its own unique IP address, and it communicates with all the other wireless devices at the layer 2 level, which means I can tell, which device has which MAC address, and I will communicate forward packets between multiple devices based on that MAC address. The reason is very simple, because the access point does not go to the internet, and therefore it does not need to know the IP address. All it needs to know is on the local area network, which is a layer 2 environment, how I communicate with multiple devices. And that destination is the MAC address.
Okay, great. So let's go back to access points for a minute. Basically, most people have a wireless router in their home, almost everybody. Either that is from their ISP that has everything all in one, or they have a modem, and then that's plugged into like a NETGEAR router, and then that router is creating a Wi-Fi network. Someone once explained to me that the Wi-Fi network on your router is sort of like an access point, and the ports on the back of the switch, on the back of the router, is sort of like a switch. But it's all combined into one device. Is that basically accurate?
Yes, it's absolutely accurate. So if you look at, let's go back, maybe 10 years, right? 10 years ago, you would have a modem, and then you would have a router, and then after the router, you put a switch, right? So from the modem to the router is a single Ethernet wire. From the router to the switch is a single Ethernet wire, and from the switch, you fan out to multiple devices. That's maybe 20 years ago, right? And then the router and the switch eventually got combined into a single unit, right? NETGEAR was at the forefront, was the pioneer in developing that router, right? That wireless, add wireless component into the switch. That's a modern day wireless router. It takes a single Ethernet cable from the modem and then fan it out to the home network, either through wire or wireless.
Right. Okay. And so what many people are doing, we ran a poll on Twitter recently that said, and the response rate said about 11% of people, instead of using their home router for the wireless, they're starting to add access points to their home, maybe multiple points in their home. So I have one here. This is a NETGEAR access point called a WAC 505. This is an AC access point. It's got just one port on the back. This is a PoE port. That means power over Ethernet. It does have a power plug option, but essentially these are powered by your Ethernet cabling if you have a PoE switch. So we're gonna need to go into that. But how would someone go about if they wanted to add some wireless to their home, some wireless access points? How would somebody do that if they're starting from scratch?
Now we're starting to get into the realm of geek talk. Okay, let's have some fun. So it's like going back in time a little bit, right? Remember the days that you have, if you're an audiophile, you will have your, power amplifier, and then you have your tuner, and then you have your, a turntable, all separate, right? The cheap ones all have, integrated, one piece. But then the expensive ones will have multiple units, right, to maximize the performance. In networking, it's starting to become like, well, for the geeks like me, it starting to behave like that too. The reason is very simple. The Wi-Fi router that is given to you by the service provider usually, I cannot say for all, right, usually does not have the best performance. I mean, they have to consider the total cost, right? It's, it's like you just can't put the best amplifier in a $600, hi-fi system. So there are trade-offs and compromise that need to be made in a all-in-one modem gateway router, right? So what do some of the people like myself, a geek, would do? That is, I would want to have a dedicated device that will provide me Wi-Fi service. Wi-Fi service. All I do is take a single Ethernet cable from the access point, plug it into the router, whichever router that is, right? Service provider router or a generic, home router. Take that very clean, right? Ethernet cable is clean. We know that, right? That's what my good friend Bradley does every single day, right? Provide extremely stable, robust communication because it's a Cat5 Ethernet cable. So take that, bring it into the Wi-Fi access point, and from there, I have high performance Wi-Fi delivery to my devices. So if I'm sitting at home, I would almost like to monopolize the use of that Wi-Fi band or that entire Wi-Fi access point, right? Let my daughter, let my family, let her friends use the generic router. They can have fun. They can go onto the internet. But for me, for my work environment, or maybe even for my own streaming environment, I want to have my own clean Wi-Fi network. That's how I do it. And I think a lot of work from home people, professionals, they would like to have somewhat of a dedicated high performance Wi-Fi network for themselves for various reasons. Does that explain? Does that answer your question?
I think that's good. So having a dedicated Wi-Fi access point for specific devices or for specific parts of the home, that makes total sense to be able to do that, and also to have complete control over your network. So yeah, that's definitely an option here. So can we maybe talk to Bradley for a second a little bit about what power over Ethernet is and how that powers these access points? Sure.
Actually, I was going to just throw in one analogy that might help. This is maybe something people can relate to a little bit as well, right? The idea of if you have a home router, a home gateway, and you have a home wireless router, right? And everyone's using that to connect. By adding in a separate access point and limiting what connects to that, right? You can say, well, my wireless home router has a guest Wi-Fi and a regular Wi-Fi. Yes, those are separated as well, two separate channels. But here's the thing. The difference between that and adding the access point is kind of like if you have a big screen TV and you have picture-in-picture and you want everyone to sit around the TV watching their program. The picture-in-picture, sure, you can watch multiple programs at once, but everybody's sharing the same screen and it's really hard. There's a lot of crosstalk and chatter, and right, obviously you can't hear the audio from all of them. But that's what's happening when you're using the guest Wi-Fi and all the other bands on one router, on your one router in your home. By adding the separate access point, it's like adding a second TV, a completely separate TV now that I can watch while the kids are watching the other TV versus we're trying to split screen on the same TV. Maybe that's a better way to think about it.
Yeah.
So you can visualize in your mind how that helps separate things and give you a better experience.
Right.
Now going to PoE. So most access points are, because they're designed to go in the ceiling or designed for businesses, are powered by what we call PoE, Power over Ethernet. I'll make it as simple as possible, and if you already know what it means, you can just ignore me for the next 2 minutes or so. But what Power over Ethernet is it's the idea that you take not just the network connection, but also the power that powers the device all through the single cable, right? So instead of having a separate power brick or little wall plug that has to go to the wall, and then the little plug into the back, and then separately you bring the Ethernet cable across to connect it, just like your current modem and everything else is set up, you just take, with the Power over Ethernet switch, you just take the Ethernet cable straight out of the back of that switch, and if your device is a PD device, powered device, you just plug the Ethernet cable in, and that powers up the device and provides the internet connection or the network connection to it. And as Doug's talking about, right in the home, most people aren't running Power over Ethernet. Could you? Sure, you could. It's also used on a lot of cameras, so surveillance cameras, security cameras. The benefit of it is when you have a device that isn't near a wall plug somewhere in your home or outside, for example, right? What are you going to do? You're going to have to hire an electrician, put in a new plug, or you've got to run a really long extension cord. So that's the benefit of Power over Ethernet. You don't have to do that. It doesn't matter if you don't have power in the wall anywhere near the device. The Ethernet cable that you're going to make the connection to the network with brings that power as well as the network connectivity. And there are all types of different types of PoE and levels of it and how much power they deliver and all kinds of other things.
Yeah, if you need more information on Power over Ethernet, you can go just Google NETGEAR PoE, and we have a lot of information, or PoE switches. There's a lot of information on our site on what to look for and everything. But in general, there's a couple formats, right? There's PoE, there's PoE Plus, and then there's a newer format that's pretty rare right now, but it's PoE Plus Plus. But essentially, it's the amount of power that can be delivered down the cable. And I think most of our current access points are PoE or PoE Plus, correct?
Yeah. So if you asked the question earlier, right? What's the difference between a consumer home router and a access point? One of that, I gave two differentiations. The third one would be it's very, very common. I have hardly seen any PoE in a consumer home router. So that is another kind of a differentiating feature as well. An access point typically can be powered by a PoE cable. So that's advantage, right? Instead of two cables, power and Ethernet going into the access point, you only need one. And then for geeks like us, there are things that you can do in the PoE switch that you can interoperate with the access point, right? There are a lot of interesting things that you can do. I mean, for one, you can use the PoE as a on-off button to your access point, right? that is one very obvious and interesting application of that PoE, controlling almost the access point.
So essentially turning off the PoE to that particular port on the switch, and then that's going to power down the access point.
Exactly.
And then you can turn it back on again. That's right. It's nice to not have to actually physically touch it on a normal kind of consumer router. They're movable, but the antennas in most access points, I have one here, it's inside, and the access point is generally designed to be on the ceiling. Can you say more about the orientation of the antennas and the shape of the Wi-Fi, I guess, signal, and how to get the most effectiveness? Do you have to put them on the ceiling to get the best signal, or is it okay to use it in different orientations and things like that?
Yeah. So when you look at the desktop Wi-Fi routers, they usually have crazy antenna. I mean, I'm from NETGEAR, so I'm allowed to say that, right? That is both for real and then sometimes for marketing reasons, right? The bigger, the fatter the antenna, the more money they're going to charge you. I mean, there's some really valid design. This is all physics, right? You all know, I mean, this is literally physics. There's some very valid reasons to have those giant antenna, and you see the antenna, separated, because that will give you the spatial diversity, so that you can have very powerful 2x2, 4x4 kind of emission of radio signal, right? In access point, though, because of the form factor, we need to go after, number one, low profile, right? Put it on the wall, put it on the ceiling. They need to be low profile, elegant, understated, just not, eggshell, matte finishes, intrusive, right? So how do we do the antenna? So we actually do not have external antenna. There are a couple models that we allow external antenna by screwing in, but most of the design by itself intrinsically will already have powerful antenna. Those antenna are laid on the printed circuit board. Okay, so from an orientation standpoint, you should know that the radial pattern looks like a donut. Okay, looks like a donut. It goes all around for the omni antenna. Okay, I'm not talking about directional antenna. For most of the the most effective radio pattern or emission sphere. So with that, our access point can function very well both on the ceiling and then on the wall. Now you think of it, supposedly it's 90-degree off face, right? How can you do it? So we took a lot of care in the antenna design so that it's omnidirectional for both a ceiling mount and a wall mount. Now that antenna design is one. The other one that has a lot of impact in the Wi-Fi signal is in the transmitter and the receiver that we choose, those components that we choose. The dBi numbers, the dBm numbers, the radio sensitivity, and then also the radio power output at different frequency, at different band. So all these things, it's not a single factor that decides the efficacy, the performance of the radio signal. It's a number of things, and of course, at the PHY layer, at the MAC layer, in the baseband layer, the DSP performance, and the firmware all contribute to the performance of the Wi-Fi radio. So don't just look at a single factor. There are multiple things that contribute to the Wi-Fi performance. At the end of the day, what you're looking for is bit rate, error rate. These are the things that you're looking for, right?
Great, thanks for that, Doug. We have another question here. Someone's asking about connecting. This is RR. He says they want to connect their office to Ethernet, but they're wondering if they should use a switch or bridge their existing router. So I think what they're saying is they want to get, Ethernet in their garage. What would be a way to possibly do that in this situation?
I see. Oh, that's a very, very interesting question. Now I understand. That's a very, very interesting question. Now look at where your router is. Ethernet cable distance, 100 meters. We all know that, right? So roughly 300 feet. So, up and down the ceiling, you can probably reach. The other way to do it is use what you call a bridge. By hearing the entire question, I think I got a good sense of what you mean by the bridge. That bridge is taking Wi-Fi signal in and Ethernet cable out, right? I think that's what you meant as a bridge. That's a really clever, that's a really clever way of extending your network down to the basement or up on the third floor, right? That's a very good, very clever design. What I would recommend you do is make sure that between the router, wherever that is in your house, and where you plan to put your bridge, make sure that there's solid Wi-Fi connection. Okay, not too many walls, definitely not too many concrete with steel beam walls. Make sure, that's going to be your backbone to your basement, right? So make sure those two nodes, NODE, make sure that those two nodes are in good connection. You can test that out. It's pretty easy. That it has very good throughput. And then you can use the Ethernet cable, and send it down to your basement. And then, of course, with the Ethernet cable, if you got a lot of wire devices in the basement, you can use the bridge, connect to a 8-port switch, and then you fan it out there. So that's a pretty good design, and it's rather common too.
So can you use an access point as a bridge that picks up the Wi-Fi network and then turns that into a local network from wherever it's connecting? So even if you have, let's say, what if I had a router, a consumer router in the front room, could I put an access point in the other room and just plug it into power or a PoE?
Correct.
And then basically pick up the Wi-Fi and then create a new network over on that side?
There's a particular mode called bridge mode that you can set up. Yeah.
Okay, great. So if you cannot run Ethernet, it sounds like that's an option.
If I can just throw in, bridge mode is a way. What you're doing is you're reversing what your normal wireless router does, right? Rather than taking a signal from a cable and then broadcasting it out and allowing wireless device to connect and come back in, you're taking a wireless device, capturing the signal and converting it back to a wired connection for a device. And then, of course, you could put a switch on the end of that to then span that out to plug in multiple devices. Now,
absolutely.
Keep in mind the drawback there is then that access point is no longer a wireless connection for other devices around it, right? You're now making it act as a receiver to turn it back into a wired connection, which is the difference between an access point in bridge mode versus the new mesh networks that we have. Mesh devices, we have Nighthawk mesh devices, we have Orbi mesh devices, etc. Those devices not only bring the signal and give you ports in the back that now make you a wireless switch, if you will, but they also allow the connections to them from the other devices. So they're an equivalent of both an AP in bridge mode and combined with a Wi-Fi extender, all in one package, which is why they're so popular these days and what makes them very powerful for really extending your network, not just wired, but wired and wireless throughout your home or across if you have a big property, etc. Right. Doug, you can jump in for more on that.
So we have the access points that we have, like the WAC 510, 505. They all work with each other, right? Now the 540 is particularly powerful because it could set up automatic band steering, load balancing. So with a single Wi-Fi device, you walk around the house, it will find the best access point to connect to. It will find the best channel in the band it connects to. I'm sure many of you know, right? You connect to 5 gigahertz band, but 5 gigahertz has 100 some channels, right? So our software will help with the band steering capability. We can actually help find the right channel to link with your device, and that is also dynamic. As you go around the house, as the weather changes, it will also find it. Some of you might even know that there's something called DFS, right? That is in the high band, the higher channel in the entire band, the frequency band. Those channels sometimes get overtaken by the government. So we need to very quickly switch over to the lower band, which is commercial home use. So these are some of the functionalities that are built into the system. Like Bradley was saying, with multiple access points, like a 540 working in concert, if I could use that word, it makes your entire environment really, really robust.
Great, thanks. So let's go back a little bit further, which is, let's assume you have a home router and you have an existing port on there that you want to add an access point to. I know the quick method would be to just put a wire straight to a access point, and if that access point has a power source, then you don't necessarily need PoE. I know we sell a couple versions of our WAC 540, I think, and the WAC 510 with an external power source. So if you did that, what would be the steps to get up and running once you've plugged into that network? How do you configure it? How do you get it set up once you've just plugged it in?
So now, if I may, let me introduce a concept as well as a product called Insight. Okay, and I'm going to walk through the steps slowly.
We also have a short video about that too, so we can show that afterwards too.
Okay, so let's say you have a router. That router is already set up, it's completely functional, okay? And it's got a name called Home 100, okay? It's called Home 100. And then you plug in this new access point into that router. Use your cell phone, and get onto Home 100. That's already in existence, right? Home 100 is already there. And then open up a tool, what we call Insight, just like how the word is spelled. Insight will discover that access point, okay? Because that access point is connected to Home 100 by that Ethernet cable, right? That access point has its own Wi-Fi, but we can ignore it for the moment, right? First, discover it. That's step number one. The discovery is by that Ethernet cable. You're connected to Home 100. Home 100 is connected to the new AP through that Ethernet cable. Once you discover that new access point, now you're able to set it up with its own distinct name, with its own distinct SSID, and then build it up as a separate, not a separate network, as a separate access point with its own SSID. Now you can disassociate your phone with Home 100 and connect to the new AP's SSID. So that's a pretty simple, easy way to set it up. And for geeks like us, I actually like to use the portal a lot, using the local admin UI. That gives you a little bit more functionality, a little bit knobs to turn. So if for you guys who want to play with it, I encourage you to do it. There's a lot of features. Have fun with it. I mean, there's rate limiting that you can do. There's URL filtering you can do. There are all kinds of knobs that you guys might find interesting. It will track traffic going to individual device, how much bandwidth you're consuming, how many devices are connected at the same. So all kinds of fun stuff there. So I would say use Insight as your regular tool, but if you want to spend some time and just tinker with it, go to the local UI and you'll find a lot of treasure there too.
Okay.
I think the thing Doug missed there is that the wonderful thing about Insight is Insight also gives you remote cloud access to that device. So now you can actually configure it, look at its status, and all the things Doug was talking about, look at the dashboard, see connection from anywhere in the world, as long as you have an internet connection on your phone, even through LT. It doesn't have to be Wi-Fi. You can, using your account, you can remotely look into that and see how the network is running and performing, which is an extremely powerful tool. So
absolutely.
You become the IT administrator for your home network when the kids call you at work and say, it looks like the network is down. You can check it and configure it and fix it, do whatever.
And I know that if you have, which I have, which is an Insight switch, I can connect that switch to Insight and also disable power over Ethernet and reboot and do things that I need to do, including installing new firmware and doing all those things right from my phone. So I find that really powerful, and that's a pretty cool tool. And since I wasn't really familiar with access points at the time, it was pretty intuitive to learn it and get it set up immediately and get up and running on my own access point network. So I thought that was pretty cool. I have Alec on the line. Alec, can you play the video? I think it's 1 minute long, the Insight access points video. And then we'll be back in about 1 minute.
Not only should wireless performance be optimal,
we'll just wait for that for a second. But the video should tell us a little bit about what access points we offer. There's a few of them in there. There's a few more that we have that aren't in that video. Here it comes. Thanks.
Not only should wireless performance be optimal, it should be easy to manage from anywhere. For the best speed, coverage, and remote management, look no further than the Insight-managed Smart Cloud wireless access points from NETGEAR. They don't just maximize your Wi-Fi performance, the Insight ecosystem makes setup and management easy, providing total visibility and the ability to monitor, update, and troubleshoot from anywhere at any time on any device. Get worry-free wireless management anytime, anywhere with NETGEAR Insight.
Maybe it's worth letting Alec know we don't see the video. It's not actually playing. Okay.
Hey, we don't see it. I'm watching it through the stream, so hopefully we're not making you wait with us just staring at the screen too long. Okay, so I think the video went through. That's good. Thank you. Yeah, so these devices are generally designed for businesses, but they're definitely easy enough to quickly learn, especially with something like NETGEAR Insight, to get you up and running and get your network built up. I think a couple of cool things that I'd like to mention that my understanding of access points, for instance, is that I think you can float like 4 SSIDs through the Insight. Is that right? Per access point?
Yeah. So currently we have 4 SSID. We're contemplating of adding even more. But of course, we know that there's a finite bandwidth that we can deal with, right? When you introduce more SSID, you are introducing a few more, command control packets. So, there's an upper limit. So right now we have 4 SSID, and that's really, really good, right? So that you can have one work SSID, and then you can have a guest SSID, and then one dedicated SSID for your IoT devices too. So there are multiple ways to use that SSID capability. So that's that's one of the uniqueness in our design in that price range, right? Typically, when you get to $400, $500 or $1,000 access points, they will give you 8 SSID. But we want to, this is what NETGEAR does and does the best, which is to bring kind of enterprise level features down to a price point that can be used in every small business and professional home users.
Great. So we got a question from the chat. This is from Dan, and he says, "Where's the controller for Insight? Is it on each device like Aruba Instant or like Meraki, a virtual machine controller in the cloud?"
It's up in the ether. It's completely cloud-based. There's no on-prem controller needed. There's a small little agent code running in the AP, and that's it.
Great, thanks for that. So you can, I know that you can also turn off Insight mode if you're not interested on some of the access points.
Of course.
So you can locally manage it. Is that right?
Yes, absolutely. So you go into the management interface on the local UI, and there are 2 modes. One is Insight Manage, and the other is local manage. Yes, you can do that. Okay.
There's a question from Chris asking about putting his Nighthawk next to his microwave. I'm guessing that's not a great idea, but I would like to hear you guys comment on it.
I have a better idea. Put that Nighthawk inside the microwave. No. It's the 2.4 gigahertz band, right? That would interfere with the Nighthawk, definitely. With just any Wi-Fi device. Wi-Fi devices operate on 2 bands, and the 2.4 is very much used by a lot of devices.
One question I had, which is, what's the number of access points you could theoretically put in an environment before it's too much, or before you need to kind of dial it back, or even just have concerns about bandwidth and other things?
Okay, depends on how and what you use it for. If you expect the access point to be completely working in a mesh environment, yes, there's an upper bound, right? for my product, at least for my products, I would not recommend you go beyond 50. Okay, so if you have a network that you expect that it will roam freely among all APs, then I would say 50 is probably the upper bound for my products. But if you use the access points individually, then of course there's no limit, right? So I want to make sure that I answer the question fully.
Great. I think one thing we haven't really talked to about that much is the instant mesh or the meshing functionality of some of these devices. Can we go into what meshing is? I know that it's multiple access points that can communicate with each other and build up a network. Maybe you can compare that to something like Orbi or Nighthawk Mesh or something like that. And how is it the same and how is it different? And what extra control do you get when you use like instant mesh from Insight?
Right. So let's go to the fundamentals first. What does mesh mean, right? Mesh means you got a bunch of access points that do not have an Ethernet backhaul. Okay, they're all individual wireless access points. All they got is a power cable, right? So there's going to be a single AP that has Ethernet, right? That is connected to the network. And then from that single AP, call it the root, all the other APs form a wireless mesh so that they all have network connectivity. So fundamentally, that is the definition of a mesh, right? Wireless mesh. So what we do, we add one enhancement over it. That is, especially in our WEC 540 and WEC 564. I'll talk about the other family next, right? The Orbi Pro. These are two different products. So let's talk about the WAC 540, 564 first. These are, ceiling mount, wall mount kind of products. What they have is that they have 3-band, tri-band, right? They have 2 5 gigahertz band and then a single 2.4 gigahertz band. So NETGEAR's enhancement in the wireless mesh design is that we use one of the 5 gigahertz band, a 4x4 radio configuration, and form the wireless backhaul in this wireless mesh. That is the biggest difference, and that gives you the most performance gain because that is a dedicated backhaul. If you didn't have that, you would have to share the Wi-Fi connectivity or connection both as a backhaul and as a front haul. So simple math will give you, if you have full traffic going on at the same time, your performance degrades by 50%, right? And then if your mesh is going from hop to hop to hop, every single time you go to another mesh node, your performance goes down by 50%. Instead, if I have a dedicated 5 gigahertz backhaul, then there's no performance degradation when I go from one node to another node to another node, right? So that's the biggest difference in a kind of a NETGEAR instant wireless mesh compared to a standard, mesh. Many of our peers in the industry, especially in the SMB space, in our price range, they really just have 2 bands. So that is somewhat, speed rate limiting. I think that's the biggest difference. The other difference certainly is our Insight, right? It discovers the devices and just connect them and really easy, right? That is the instantness in our instant wireless mesh.
Great, thanks. And just to let people know on the chat, if you have questions, go ahead and send them in chat and we're going to try to get to them. There was some questions about having wireless near an airport, whether that would be a problem. Maybe you guys can just chime in on that quickly.
Yeah.
And I'll see if there's more questions.
Yep, just like I said, right? Earlier I talked about this concept called DFS, right? Boy, I don't even remember what DFS means. Frequency spectrum. I forgot the D, maybe dynamic or something, right? So in the 100-some channels in the 5 gigahertz band, the higher channels, in fact, the majority of that 100 some channels are actually so-called Tfs channels. So by law, this is by law, the government has priority on the use of those channels, right? So what do they use it for? Originally, many years ago, it was for a weather station, right? They have priority. But later on, the airport authorities would use it, and then some other government agency, right? So by design, if you want to be compliant to the FCC rule, you need to back off from that high band as soon as a signal from the government station is detected. So that's all taken care of in the software. You don't need to worry about it. The software takes care of it because we need to be compliant to FCC rules and to, when we sell it into Europe, to be compliant with the EU rules and all the local governments, right? Most of them actually do follow the the DFS rule. That is, the higher bands are prioritized for governmental use. So what do? We back off. We obviously back off. And the other thing that is good is that when you have a dual 5 gigahertz band, you can, on a good day, if the government is not around, you can actually have both bands running for yourself, for your own use, right? When the government comes in and uses the higher band channels, you still have that connection in the lower band still ongoing, right? So a tri-band design with the 2 bands in the 5 gigahertz band actually performs almost like a fault-tolerant, failover, redundancy kind of a Wi-Fi network for you.
Thanks for that. That's interesting. Here's a question from Dan. He says, is it better to use the 80 megahertz or the 20 megahertz channel for Wi-Fi? Your results may vary.
Yeah. So first of all, that's not a channel. That's a frequency of the Wi-Fi encoding. But I'm sure you understood that. So having said that, first of all, physics. The higher the frequency, the cleaner the medium needs to be, right? Because your DSP capability. So it's not up to you, actually. In our software, in our firmware, we detect the quality of the radio signal, the link, and decide what frequency of the encoding algorithm that we use, right? That's all in the firmware. If it's super clean, we go to 80 megahertz. If it's not clean, we back down to 40. If it's still not clean, we back down to 20. So there is the speed implication or ramification, right? 80 megahertz will give you, a 4x4 will give you 1.7 megabits per second, right? 1733 or something like that. You can look it up. And then if it's 40, then it's 50% of it, and so on and so forth. The firmware will choose that for you. In the GUI, now, if you're a geek just like me, that's what I meant. These are the things that you can tinker with. You can manually set that you're always communicating at 20 megahertz or 40 megahertz. You can make your own choice. Now, I can't think of a really good reason to force the firmware to not interoperate at a higher frequency level. But I mean, there may be reasons that I'm not aware of, and there may be just things that people want to have some fun with.
Okay.
I hope that answers the question.
I think it does. I think that in general, it looks like it's going to auto pick whatever is best for the current situation. So that sounds pretty
right.
accurate. But if you want to force it, you could theoretically.
Right. And I think Dan also had a follow-up question. I am reading the notes here. Yes, there's a 160 megahertz thing, right? There is. And that will give you even more throughput. But in reality, I mean, this is really, really deep geek talk here. The 160 megahertz actually has a significant it has only one channel, right? So if it's not clean, if the signal is not clean, then it really renders that 160 megahertz almost useless, right? So it oftentimes the firmware will back down to 80 megahertz, or that 80 megahertz is pretty efficient, very productive. 160 because you only got one channel to deal with. You can 80 megahertz, you can bounce back and forth between multiple channels, and say if this channel is not clean, I bounce to the other channel, right? 160 megahertz, you got only one channel. So the likelihood of actually establishing a stable, constant communication, it's pretty tough. It's pretty tough. So 160 give you a really high number, in terms of throughput, but in reality, 80 megahertz is a very, at this point, a very kind of a mainstream kind of, medium.
Okay, great.
Yeah.
So I have a question. I think that's it. Oh, please, Brett.
Throw in. On. Yeah. So
yes.
There's been a lot of talk about it, and if the people on are geeky, they probably already know this, but the biggest mistake most people make with their wireless router, their gateway, is they put it behind the TV or next to a computer or somewhere next to other electronic equipment because they want it close to where some of the stuff is that they're using. That is probably the biggest mistake. You need to get it as far away from other electronic equipment as possible so that the signal can radiate out unimpeded. As soon as you put your wireless router behind the television is a great big wall that's creating interference like crazy for your signal. So try to get as far away as you can. Don't just use the little included, 3-foot Ethernet cable. If you can, put it farther away. Go buy yourself on Amazon. They're cheap, a couple dollars. Get yourself a 25-foot Ethernet cable and run that across. You can use a switch if you need to, but get your device away, and the closer to the center of your room that you can get it is always better. And then I'll just end with, the other way to really improve your Wi-Fi performance anywhere, whether it's a business network, home network, or anything, is wherever you can, if you have devices that can be wired, wire them, because that takes the load off of the Wi-Fi, right? So if you have a streaming TV and you use streaming services and you have either the modem or the gateway or a switch nearby, plug it into the wire. Don't run it over the wireless, because you're hogging all that bandwidth from all the other devices in your house for that one device. So anytime you can have a wire, use it. It's the equivalent of the old telephones. If you had a wired connection, it was way better than wireless. As soon as you have wireless and you start walking around, you get static, you get interference. So the more things you can take off that wireless network, the better the wireless performance would be. And that's to the point of this webinar, if you want to call it that or whatever, right? As well as what Doug's saying is, when you add that other access point, you're also taking load off the current home router. So you're separating some of those wireless devices and getting them off, so everybody's not competing for one way into the internet, if you will.
That makes sense. So we're getting close to the end, but I thought, Doug, I would give you a chance to just mention the Orbi Pro product, that we can kind of discuss how that's a little bit different than an Insight access point. Let's talk about that for a minute, and then we'll wrap things up.
Okay, so if you use the Geek Meter, the WAC are really really good geek products. The Orbi Pro is a little bit less geek, right? Geeky. It's a beautiful form factor, nice design, and everything. The design feature, if you call it, is that it really is a Wi-Fi system. So it's got one base unit and then multiple satellite units, and they always form a wireless backhaul. So that's by default, right? In the access point, you have your freedom. That's the geekiness of it, right? You can use wireless backhaul. You can put Ethernet as your backhaul. But in the Orbi Pro, by default, it is a wireless backhaul Wi-Fi system. Okay, so that's the biggest difference. It has a couple, fewer features compared to the WAC line, and the Orbi Pro is desktop, and we do have one satellite that is a wall mount and ceiling mount. So that's the biggest difference.
Cool, thanks. Is there any last things you guys want to say before I wrap things up?
I hope you enjoyed the talk. I hope that was informative. I certainly hope that you take up one or two of our products, play with it, have fun for your own use, and for your friends and for your customers if you are in the kind of a retail, a reseller installation business.
Cool. Thanks.
And I thank you for your time.
Thank you for your time.
Most important.
Thank you guys thank you too for coming. I really appreciate it. If you want to reach out to us, you can always come to the NETGEAR community. We have our own community site, but you can also leave us a message on r/NETGEAR. We monitor that. We keep an eye on it. Or just track us down, and we'll try to answer your questions and get you set up. And if you do try to use a wireless access point, definitely take a look at the NETGEAR Insight products. We have a bunch of different access points. They can all connect to NETGEAR Insight. And if you don't want to use Insight, you can manually configure them. But they're very competitively priced, and there's a lot of nice features that they have. And I think we do have some sales in the NETGEAR store right now. If you go to store.netgear.com, we do have most of our access points there too. So I just want to thank everybody for coming. Thanks for your questions, and if you want to do another one like this, just reach out and let us know. This was nice. Thank you so much for joining today.
Thank you.